We're going to be talking about writing equations in point-slope form. We'll be finding the slope average rate of change as one of our learning targets, which we've done before. We will be writing a linear equation in point-slope form given 2 points, and then we will construct a linear model for a linear scenario. So by the time that we're done with this video, you will be exposed to all of these learning targets. You'll obviously get to practice these learning targets when we get to the homework, but just wanted to give you a heads up. This is where we're going. So point-slope form is different than slope-intercept form. It's just another way to write a line. I personally think this is the easiest form. However, most students would disagree with me, and they like slope-intercept form, and that's because they've been exposed to it more. And that's totally fine. Everyone has their own opinion. But point-slope form, you're going to have a point at x1, y1, and you're going to have a slope. All right, so then this form is y minus y1 equals m times x minus x1. So what I'd like to kind of reiterate here, because this gets tricky, this x1 is represented here. The y1 is represented here. Now notice something here. x1, y1 go in opposite of what you see. And we'll talk a little bit more about this when we get to an actual example, but you guys know for sure this is critical information. You need to make sure that you put this on your frame. It is very valuable for you. This is telling you your formula as well as what is what, and kind of gives you some hints. Okay? So make sure you're putting this on your frame. I would pause the video and then go ahead and write it down. Example 1. Write an equation of a line in point-slope form with the given information. So we have our slope and we have our x1, y1. So I'm just subbing it into my formula. And this is where that x1, y1 go in opposite of what you see. This is where I'm talking about. So because y1 is negative 9, I'm actually going to, because it's negative, I'm going to change this to be a plus 9. It is opposite of what I see. My m stays the same, and then I have x, because it's positive 8, I'm going to have it as minus 8. So that goes in opposite of what I see. So I'm just subbing in my information into my equation there. If there's not an x1 or a y1, what I mean by that is if it doesn't have that subscript, we leave it, okay? When you think about slope-intercept form, we have y equals mx plus b. And our equation could look like y equals 2x plus 6. Okay, I still have an x and I still had a y. Same thing in point-slope form. You still have an x and you still have a y. It just looks a little bit goofy, but it still actually is there, okay? So example 2, write an equation in point-slope form from the graph. I have 2 points, which is great, and it doesn't matter which point you want to use. I'm going to use the 1 and the 2 as my point. Again, you could use that 3 and negative 2, it's up to you. But my problem is I don't have a slope. However, I do have 2 points in which I can find that slope. So remember, slope is y1 minus y2, or you could do it y2 minus y1, does not matter, over x1, x2. Okay, so I have 2 minus negative 2 over 1 minus 3. This ends up being 4 over negative 2, which gives me negative 2. Now some of you might be saying, Mrs. Fish, I could look at the graph and I could count my rise over your run, and you'd be correct. You could. What that means, we are going down 4 and to the right 2. So if we do that down 4, right 2, down represents negative and right is our positive. and we'd still get up with the same thing. So you could either use the graph by itself, or you could use the slope formula. It doesn't really matter. Just pick your poison. All right. So now we need to write it in point slope form. I have my point and I have my slope. Point, slope. I'm going to unhighlight that 4 though. That way we don't get confused. So I have y minus 2 equals negative 2 x minus 1. Again, my point was a positive 1 and a positive 2, so it went in as negative 2, negative 1. Example 3, write an equation in point slope form that goes through the 2 points. Again, does not matter which point you're going to pick, if you want to use the 4, 6 or the negative 1, positive 2. I'm going to go ahead and use the 4, 6. On this situation, I obviously don't have a graph that I could look at, so I'm going to have to use that slope formula, which is not a big deal. Remember, y minus y over x minus x. So I have 6 minus 2 divided by 4 minus negative 1. And remember, these vertically have to match up with your point. Just a refresher. So 6 minus 2 gives me 4. 4 minus negative 1 gives me 5. I now have all of my needed information to write my formula. So I have y minus 6 equals 4/5 x minus 4. Now example 4, this is similar. You could pick your 2 points and go from there. It doesn't matter which 2 points you pick. For me, I'm going to go with the 1 and the 4 and the 3 and the negative 2. Again, you could pick any points you want, because we already know it's a linear equation, so we don't have to worry about whether or not if it has a bend or a curve. We already know it's linear. Okay, so I have 1, 4 is my point, and 3, negative 2. Now it's just like example 3, so not a big deal there. I'm going to use the 1, 4 is my point, and then I got to figure out that slope. So I have 4 minus negative 2 divided by 1 minus 3, which gives me 6 over negative 2. Reduce that down to negative 3. Notice every time I'm writing down the general point slope formula there, just so I can see where everything is going. You don't have to do that. That's just something, you're not as familiar with this form, so it might be easier if you write it down so you could see where stuff is going. So I have y minus my 4 my m is negative 3, and my x is that 1. Again, 1 and 4 were both positive, so they're both going to be a minus there. Go ahead and flip the page. Now example 5, which meets our last learning target. You're designing a sticker to advertise your band. A company charges $225 for the first 1,000 stickers and $80 for each additional 1,000 stickers. Write an equation that represents the total cost of the stickers as a function of the number of stickers ordered. Okay, so this gets a little confusing as far as what is what. What's my x? What's my y? Okay, because it's a function of the number of stickers ordered, that's our x. Number of stickers. So my y then is the total cost. Okay, so when I look at this, there's a couple different things. So I know initially that for 1,000 stickers, I have been charged $225. But for 2,000 stickers, I'm charged $225 plus 80. Okay, so that plus 80 is 305. All right. So I realistically have here 2 points. I have a point at 1,225 and a point at 2,305. From here, I can go ahead and write my equation. I'm going to use this as my point, and then I'm going to find that slope. And sorry, because of spacing, I'm kind of running into my b. I'm sorry about that, but it'll help us in the long run anyway. So we have 305 minus 225 over 2,000 minus 1,000. So that's 80 divided by 1,000. Okay. No surprise, just because we have that 80 for each additional 1,000. Okay, so this is my m, and this is my x1, y1. So my equation, y minus 225 equals 80 over 1,000. Yes, you could reduce that. I'm just going to leave it how it is because of the context. X minus 1,000. All right, so there's my equation. Now for part B, I am supposed to figure out the total cost of 9,000 stickers. So X is 9,000, Y I'm trying to figure out. So you just have to take that X and sub it in here and then solve. Okay, so I have Y minus 225 equals 80 over 1,000, 9,000 minus 1,000. So when I do that, I'm gonna get, just on the right side alone, .2. That doesn't seem right. Sorry, working on different function here, and it's just kind of not working how I want. So you should get 640. That makes a little bit more sense. And then we will add over that 225. So y equals $865. And there we go. There's our final answer. So just using that point slope form, just reiterating here. X1, Y1, we need a point, and we need our slope. Our equation is y minus y1 equals mx minus x1. The x1 and y1 go in opposite of what you see. If you don't already have this formula on your frame, make sure you do. Also, make sure you have the slope formula on there. I know we talked about it in section 4.1, but just make sure that you have your slope formula on there. It is vital for this in order to write your equations. So we've talked about finding the slope based on 2 points. We wrote a linear equation in point slope form given 2 points, such as example 2 and example 3. and construct a linear model for this linear scenario. We did that in example 4 with a table and example 5 with our story problem.